let's try a couple more here. Below, I need to get the x alone. We need to get the x by itself, so we're going to bring it down. So I'm going to take a logarithm that allows me to bring it down, but I'll do a log base 2 because that is just saves me a step later on when I cancel this. I can cancel this 2 out. There and there. So I can bring this x squared down and turn it to a multiply. And I'm just left with a log base 2 of 2. And this is a log base 2 of 10. And then this is gone. So I just have an x squared equals log base 2 of 10. This says, by the way, 2 to the what gets me 10. Some people might think, oh, it's 5, but no, there's no way we can, or there's no exact answer to this. It's going to be some decimal. 2 cubed is 8, and 2 to the 4 would be 16, so we kind of just skip 10. And then I can square root. So I get x equals plus or minus the square root of log base 2 of 10. And you can do a decimal approximation. I did it in the notes. It's apparently approximately plus or minus 1.8. But it's not necessary here. We always try to find the exact answer, not the decimal approximation. The decimal approximation is helpful later on, just to plug things back in and just to kind of get a sense of what the number is. Like, I have no idea. I had no idea what this is. Now I know it's just under 2, but just looking at it, you would have no idea. So I need to get the x alone, which means I need to get this 4x alone before I log both sides. So I need to do backwards bedmass here. I'm going to get rid of the 4 and the 5. So we have 5 times 4 to the x. I didn't put a dot, I put them in brackets just because. Equals 25, and then I can divide by the 5, divide by the 5. So I have 4 to the x is equal to 5. And now I can do the log, because the log will allow me to bring this x down below. So I can take the log of both sides. I'll do a log base 4, because that will delete this 4 later. It'll get rid of it, just to save me some work. So you'll often see people just kind of cancel this out even right here without showing that you bring the x down. It's nice to show all your work, but I do understand that it's a little bit faster. So x times log base 4 of 4 equals log base 4 of 5. That cancels out, and it's just x equals this. I'm not going to rewrite it. It's already rewritten in the notes. So that's our answer, log base 4 of 5. Again, I have no idea what that is. So it's kind of nice to have a decimal approximation just to know, like, what is this number? It turns out it's around 1.2. Okay, so I need to get this e alone so I can get this exponent down. So the first thing I'll do is I'll times the numerator by -4. That way the numerator and denominator can cancel out. So I have e to the 2x is equal to positive 100. Now you could log both sides to take this down, but I'm going to take the natural log. It'll just save me a step because the natural log will cancel out the e. So now I can bring this 2x down below, turn it to a multiply, and you're left with ln of e equals ln of 100. Now that's gone, that cancels out. So I just have 2x equals ln of 100, and then I can divide by 2. Now you have to just leave this as ln of 100 divided by 2. You can't make it a ln of 50. This is just the answer. This 100 belongs to the natural logarithm. It can't just belong to the 100. So you can't just say the 100 becomes a 50 because you cut it in half. No, you leave it separated. So this is our final answer. Again, without a decimal approximation, I have no idea what this roughly is. Turns out it's approximately 2.3. Okay, so what I'm going to do now is I'm going to continue on down below and just to kind of show you a little bit of, oh, maybe we'll do a couple of them. So what we'll notice, well, actually what we won't notice, we'll do B first. What we notice here is well, yeah, we just have an x. I mean, it's got a 3x plus 1, so it's a little bit more complicated, but it's not too bad, actually. So we need to first get this exponent term alone, just the 2. We want to get rid of this 3. So I've got a 2 to the power of 3x plus 1 is equal to 16. Now I'm leaving some space here because I'm going to take a logarithm. Now I'm going to go log base 2. I'm choosing log base 2. Again, I say this all the time just because it'll be nice for us to cancel those 2's out after. So I'll bring this down and I will get a 3x plus 1 that will now multiply. So I'll put that in brackets. Log base 2 of 2 equals log base 2 of 16. Now what we notice here, well obviously as that's gone, is that this is a number. I think this is just 4. 2 to the what gets me 16. And so, well, 2 to the 4. 2 times 2 is 4 times 2 is 8 times 2 is 16. Yeah, so this just becomes a 4. And this is just a 3x plus 1. So now I can subtract the 1 over. So then I get 3x is equal to 4 minus 1 is 3. And then I can divide both sides by 3, and x will become, I'm running out of room here, so x will become 1. Okay, so there's not much different about that, except that the number that I got was required a little bit more work because it was something that I could actually find out. It was a number that wasn't a decimal, so that's actually quite nice. Okay. So what is different about B? Well, you should see immediately that we've got exponents on both sides, x's, unknowns on both sides. So that is the thing that's different. Now, there is a way to do this with a common base. There's a completely different way to do this. I'm not going to do that. All of these questions, I want to do them the same way. So that's how I'm going to teach it. All of them have numbers with an x in the exponent. And for all of them, we're going to solve using logarithms. There is a way to do this without solving logarithms. It's kind of like just like a sneaky way to do it, but it's really specific, so I'm not going to bother. So when you get these, you want to make sure that you have a log on each side, which I do. So I am going to take the log of both sides. Obviously, I want to do that because then I can bring the exponents down. So 4 to the 2x minus 1 and 8 to the 3x plus 5. So your job here is to figure out, and so if there's see if there's a base here that'll work for both of them. That when you bring this down, it'll cancel out or it'll make a nice number. If it won't work for both of them, which you'll see in example, I think it's example 3, where there's no possible way to choose a nice one. We'll get there. Then I end up just choosing log base 10. But I can make things a little bit easier on myself by choosing log base 2. And you'll see why here. I'll bring this 2x minus 1 down as a multiply, and this 3x plus 5 down as a multiply. 2x minus 1 and 3x plus 5. And then this is a log base 2 of 4 and log base 2 of 8. Now the reason I did log base 2 of 4, or I did log base 2, is because 2 to the what gets me 4. Well, that's just 2. 2 squared does. And so this just becomes a nice 2. And then log base 2 of 8, that's just 3. 2 cubed gets me 8. So I chose log base 2 because because both of these can be evaluated and become nice whole numbers. So that's how you know that you've chosen the correct base. Except for, obviously, example 3, and we'll get there. So now I can bring this 2 in, so I get a 4x minus 2, I can bring this 3 in. I'm going to get a 9x plus 15. So now I can bring over, I'll move this 4x over. I'll subtract the 4x away onto this side. And then I'll subtract the 15 onto this side. So I guess this ends up becoming a negative 17 is equal to 5x. Divide both sides by 5. And x equals negative 17 over 5. So that's that's a nice number. That's not a bunch of random decimals. It actually is just a simple fraction. So I will zoom here where you can see both of these, but the answer keys are obviously already uploaded as a PDF. You can just take a look at that. And we'll do the next 4 questions that are going to be done very similar to this, but they do get progressively more difficult. So the only thing that's important here is to choose the right base. So this one was the one on the left here. I chose base 2 because those canceled out, and this one got me a 4. I chose 2 here because this becomes a 2, and this becomes a 3. So choosing the right base is really important to getting these really nice numbers.